In this problem, we're given a string of numbers, and we have to return the number of ways to decode it. Decoding is based off of this mapping, so numbers 1 to 26 are mapped to whatever letter they correspond to in the alphabet, and leading zeros are not valid. So, as an example, if we have the string 1, 2, 3, we can first decode the 1 by itself, which is an A, and then we have to decode the remainder of the string 23. There's two ways to do this. We can first take each digit individually, which would be BC, or we can choose to decode the 23 together. So that gives us the decoding AW. Alternatively, we could have decoded the 12 together, and then the 3 is the rest of the string. So that gives us the decoding LC. We see that we had two choices. We can choose to decode the 1 by itself, or the 1 together, the 2 as a block. So we can write this in terms of two subproblems. The number of ways to decode 123 is the sum of the number of ways to decode 23 and the number of ways to decode 3. This first term came from when we chose to decode the 1 by itself. 23 is the remainder of the string. And then this term was when we chose to decode the 12 together, and then the 3 is the remainder of the string. If we look at a different example like 4, 5, 6, we can decode the 4 by itself, but we can no longer decode the 45 together because that exceeds 26, and that's as far as the mapping goes. So the number of ways to decode 4, 5, 6 is just the number of ways to decode 56. And 56 is the remainder of the string after we decode the 4. And as a final example, we have 10. We can first decode the 1 by itself, and then the remainder of the string is a 0. Or the second way is if we decode the 10 together, the remainder of the string is just the empty string. So for the math to work out, decoding 0, there should be 0 ways to decode this because leading zeros are invalid. And then decoding the empty string, we can say there's one way to decode this. So then there's one way to decode 10. So we can see that we can formulate this problem as a sum of two subproblems. So we can solve this problem recursively. We can also write this as iterative dynamic programming, which both solutions will be O of n time complexity, and I'll be showing both in the code. To write this recursively, we start by defining dictionary to cache our results. That way we don't recompute subproblems. If we've computed a subproblem, we can just return it. Then if we see a string with a leading 0, that is invalid, so there are 0 number of ways to decode it. Then for our base cases, if we see a string of length 1 or less, there's only one way to decode it. For a recursive case, we can first block off the first digit, so we add the number of ways to decode the remainder of the string. And then if the first two digits is less than 26, we're able to block off those two digits, so then we can add the number of ways to decode the remainder of the string. And because we blocked off two digits, our string slicing starts at 2. We then just cache our result, and then we can return the total. So this will pass on Leetcode. Now I'll be showing how to write this iteratively. We can create a dynamic programming array where the ith entry represents the number of ways to decode string s starting from index I, and the empty string only has one way to decode it. Now we iterate backwards using our base case to fill in the rest of the array. If we see 0, we know that's invalid, so we can just continue because we initialized our array to zeros. Then in the first case, we can section off just the first digit and add on the number of ways to decode the remainder, which is I plus 1. Then if we're in bounds, we can check the current character with the adjacent character, and if that's less than 26, then we're able to decode that pair. So we just have to add on the number of ways to decode the remainder. And because we're sectioning off two digits, the remainder starts at I plus 2. Then we return dp of 0, and that's our solution.